Looking at this next sequence, 5/3, 5/6, 5/9, 5/12, I can rule out fairly quickly that this is not an arithmetic sequence. We're not adding the same amount to each number each time. 5/3 plus an amount to bring us up to 5/6 is not the same amount that would take us from 5/6 to 5/9. It's also not increasing or decreasing via multiplication. We're not multiplying by the same amount each time. To go from 5/3 to 5/6, you would multiply by a half. To go from 5/6 to 5/9, you would multiply by 2/3, which is not the same amount. So it's not arithmetic, it's not geometric, it's something else. And so if we're thinking about our sequences that we've got here, our sequence, and I'm going to just write down the first few terms: 5/3, 5/6, 5/9, 5/12. We might want to start by making some predictions. And so one thing that I notice here for this, every single term of my sequence is a fraction, and every single term of my sequence has 5 as the numerator. So I'm predicting that the fifth term of the sequence should have 5 as the numerator as well. I'm looking at my denominators, 3, 6, 9, 12. Each denominator increases by 3, so I'm expecting the next one to be going up from 12 to 15. So now, the next thing to think about is, what sort of pattern do we happen to see in these numbers, in these numerators and in these denominators? And hopefully that'll help us to figure out the general formula for the nth term in the sequence, Fn. We already know one part of the formula, which is every single one of the numbers in the sequence has 5 in the numerator. So in the general formula for the nth term of the sequence, I'd expect 5 to be in the numerator as well. The next thing to think about is those denominators. What sorts of numbers are those in the denominator? What do they have in common? If I'm thinking about 3, 6, 9, 12, 15, hopefully I'm thinking about those numbers all being part of the 3 times table. That 3 is one group of 3, that 6 is 2 groups of 3, that 9 is 3 groups of 3, that 12 is 4 groups of 3, and so on. Now I want to say to myself, well, the denominator seems to always be some multiple of 3. 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3. What should I expect for the denominator for the nth term? So now I need to start thinking about the relationship between where I am in the sequence and how many groups of 3 do I have. When I'm in the first term of the sequence, it's 1 group of 3. When there are 2 terms in the sequence, the second term is 2 groups of 3. The third term in the sequence, the denominator is 3 groups of 3. For the fourth term in the sequence, 4 groups of 3. And for the fifth term in the sequence, 5 groups of 3. And I would expect then for the nth term in the sequence, there would be n groups of 3. It looks like this should be the pattern that I have, which I could write as 5 over n times 3, or more compactly, 5 over 3n. That this would be a formula that does generate all of the terms of the sequence. When I have 1 for the first term, when I have 1 for n, this does give me 5/3. When we're talking about the second term, when n is 2, this formula will give me 5/6. For the third term, it will give me 5/9. For the fourth term, when n is 4, it will give me 5/12. And it also gives me the term that I predicted. When I put in 5 for n, the fifth term, it does give me 5/15, the term that I predicted. So I have that my formula for this sequence, the general formula, 5 over 3n.